Hi, this is Alex from devstories.eu. Shapely, episode 5 of 8. Venn diagrams are not just for logical sets or database queries. You can use the exact same mathematical principles to physically carve up real-world geography. To do that, you need set-theoretic operations. In Shapely, every geometry is essentially an infinite set of points on a two-dimensional plane. Because they are sets, you can manipulate them using classic set theory. First, we must clear up a common source of confusion. Spatial predicates, like checking if two shapes touch or cross, evaluate a condition and return a simple true or false. Set-theoretic operations do something completely different. They return entirely new geometry objects. They take two input shapes, analyze their overlapping points, and construct a brand new third shape as the output. Consider a concrete scenario. You have two polygon datasets. One represents an old flood zone map. The other is a newly updated flood risk model. You need to calculate the exact area where these two models agree. For this, you use the intersection method. You call intersection on the first geometry and pass the second geometry as the argument. Shapely looks at the spatial overlap and returns a new polygon containing only the points that exist in both the old map and the new map. If the two shapes do not overlap at all, it returns an empty geometry. Now, what if you need to find the strictly new risk areas? These are the neighborhoods that were safe under the old map but are now in the updated flood zone. Here you use the difference method. You take your new flood model geometry and call difference, passing in the old map geometry. This returns a shape containing all the points in the new model explicitly minus any points that were already in the old one. Order is critical here. If you reverse it and call difference on the old map passing the new model, you get an entirely different result. You get the areas that are no longer considered at risk. It is just spatial subtraction. Sometimes you do not want to compare shapes, you just want to combine them. If emergency services need a master map of anywhere that has ever been flagged as a flood risk, you use the union method. You call union on one shape, pass the other, and Shapely merges them together. If the shapes overlap, the internal boundaries dissolve. The output is a single continuous geometry representing all points from both original shapes. Finally, there's the symmetric difference method. Think of this as the spatial equivalent of an exclusive OR operation. It returns a new geometry containing points that are in either the old map or the new map, but absolutely not in both. In our flood scenario, this single operation gives you exactly the areas of disagreement between the two models. It outputs the newly added risk zones alongside the newly removed risk zones, completely hollowing out the areas where the models agree. Here is the key insight. When you stop thinking about spatial boundaries as complex geographic concepts and start treating them as basic mathematical sets, calculating complex overlaps and exclusions becomes a predictable, completely standard process. That's all for this one. Thanks for listening and keep building.